During this course, you've probably learned a few approaches for managing state between a parent component and a child component. But have you wondered how well these approaches still apply for more complex apps with multiple levels of components? Fortunately, there are tools available to help you do just that. By the end of this video, you will understand how Context API can be used to manage state more efficiently across multiple levels of components. You'll also be able to perform basic state management using the useContext and user-reducer hooks found in Context API. By this point, you're probably familiar with the practice of passing state from one component to another by using props. While passing props helps to manage state, it is like taking a bus and going through each stop before you get off at the end. In comparison, using the Context API is like teleporting to your destination instantly. It's a way to bypass the redundant passing of data through multiple levels of components. Remember that API stands for Application Programming Interface. An API provides a predefined set of ways you can interact with some code. The Context API thus provides a streamlined way to work with context in React. To set it up, you need to add a piece of code that will be your context provider and is also where the state will be stored. When a component needs to use the state, it becomes a context consumer. Now let's examine a simple app that utilizes the Context API to control state. In my app.js file, I'll use some code for a starter setup, and you can also find this file in the additional resources if you'd like to use it to practice working with Context API. In the app component, I have import statements for meals provider and meals list. The meals provider provides context state data and gives it to all the components it wraps inside the app component. Currently, it wraps two components, the meals list component and the counter component, which are between the div tags of the return statement. The meals provider component holds all the state, which is organized with the help of the Context API. First, I set the meals context variable using the react.createContext function. Next, I declare the today's meals array, which contains several food items saved as strings. I then code the meals provider as an ES6 function that accepts the children value. This value holds everything that will be wrapped into the meals provider component when it gets rendered inside the app component. The children value is just returned from the meals provider, wrapped into the meals context.provider JSX element. The meals context.provider JSX element comes with the value attribute, and this value attribute gets assigned the meals object, which is the value I set to the useState variable earlier. Before exporting the meals provider component at the bottom of the file, I'm also setting the useMealsListContext variable to the react.useContext call and passing it to the meals context as its single argument. This makes it easier for me to destructure the meals object from the useMealsListContext variable. Finally, in the meals list component, I'm accessing the context state by importing the useMealsListContext from the meals provider file. Let's break down how this component works in more detail. First, I'm destructuring the meals property from the objects returned from the useMealsListContext call. The original object has a single property named meals, which holds an array of 3 meal strings. Once I destructure the meals property from that object, all I have left is the array of 3 strings saved in the meals variable, which allows me to map over the meals value, where I'm rendering an H2 for each member of the meals array. This code is probably more complex than most of what you have encountered. Don't worry if it takes time for you to understand how it works. Just remember the important parts, that this setup gives you a nice starting point for working with the Context API. And lastly, let's examine the counter component. Note that it gets the context data in the same way that the meals list component does. This is the usefulness of having a centralized state store. It allows me to simply reach into the state provider directly from whatever component needs it without having to do prop drilling or lifting up state. Next, let me show you how the useReducer hook works. Let's move on to the useReducer hook. You can think of it as a superpowered useState. While the useState hook starts with an initial state, the useReducer also gets a reducer function in addition to the initial state. Let me illustrate that with a code example. Let's say I have a rideshare app that represents the amount of money in my wallet. The initial state is a value of 100, and the action of picking up a customer increases the value, while the action of refueling my vehicle decreases it. I've applied a reducer function which takes in the state and the action. Instead of using setState like in the useState hook, I use the dispatch method of the useReducer hook, which accepts an object literal with a single property, type, set to a matching action.type, whose behavior is defined inside the reducer function. Now, when I interact with this app in the browser, I can increase the money value by clicking the A New Customer button, or decrease it by clicking the Refill the Tank button. In this video, you learned how the useContext and useReducer hooks can be used to manage state more efficiently across multiple levels of components.